Welcome to my demo of the Employee Programming Challenge entry. This is the Gaia Planetarium. So the challenge, for those of you not aware, was use the publicly available Gaia photometry archives to identify characteristics whose flux has changed more than 100% over the period observation. And this outputs a dataset which looks something like this. Now, I thought this was a bit of a boring way to view the data, so I decided that I would like to view it visually in the night sky above me. And so I built the Gaia Planetarium. So let me start with nothing on and talk you through it. So this is the night sky above me. I can choose where I am. So I'm currently set to be in Boston, but let's put this to where I actually am in Edinburgh. It's somewhere around here, and let's refresh. So these are the stars above me. Now, at first, I processed the challenge data only, which gave me a very short space in the sky that was here. So the photometry archives themselves don't contain the star's location, so I needed to query the Gaia source table. So I used a interoperability production to build this workflow. But I quickly realized that the photometry archives only cover a very small amount of sky. And if I wanted to cover the entire sky, I would need many gigabytes of these archives. And that just wasn't plausible, particularly as I was using the community edition, which is limited in space. It probably wouldn't have fitted in there anyway. So I decided instead to add in stars that weren't in the photometry archives. So this is from the Gaia source table. So these are all Gaia stars. I'll get rid of the challenge overlay. And then I decided to add in some constellations. So these are constellations from Stellarium, which is an open source application, which actually does similar things to this. And I noticed that most of these constellations, the stars were missing. So that made me query another data set, which is the Hipparcos stars. And I also added in some star names, but once I added these, I realized I wasn't actually that interested in them. So the whole thing is built in Python. It uses a Flask front end, which is hosted, a Flask backend. So this is hosted on Iris with WSGI hosting. And it calls a Python production. So the data is saved into Iris tables via a PyProd production. Via the components are defined something like this. And one nice thing is that if I want more stars to be added, maybe I don't have enough stars, I can press fetch new stars, and this will call from Flask via the let me find it in the server. This is my Flask file. It will create a new business service and call process input, and that will call the production to add more stars in. And hopefully I've given it long enough. And if I refresh, I will see, yes, it went up from 700 to 1,218 above me. So I can add new stars in that way. And I can refresh the sky, and I can change the number of stars I'm plotting or the magnitude. So at the moment, these are stars of any magnitude, but maybe I'm more interested in the stars that are visible to me, which are more like magnitude of 4.5 or below. So if I refresh the sky with that, and I just see it's mainly the Hipparcos stars. So these don't appear in the Gaia dataset because they're too bright. So they tend to be much brighter. But these are more what we see in the night sky. So it's been a really fun project for me. I've learned a lot more about the stars, about how we plot the stars in the night sky, and about the datasets available, and about using Flask and PyProd. So it's been really fun. I've enjoyed it. I hope you've enjoyed this demo too. Thanks for watching.